Alright guys, in this video we're still talking about limits, but what we're going to do is we're going to evaluate limits analytically and look at the indeterminate forms. So if I'm evaluating a limit, a lot of times I can just plug in the number. Like if I want to find the limit as x approaches 3, we're just going to plug in 3 and then see what the y value is there. So it says, while the value concept of limit works both continuous and discontinuous, which we're going to talk more about coming up, the AP exam will target functions that are not continuous. However, if working with a continuous function, don't overcomplicate things. With a continuous function, the limit is simply the same value as the actual point on the graph. So this one, I can kind of know the graph is a parabola. I want to see what is the y value when x is 3 right there. So I'm just going to plug in 3. So I have 2 times 3 squared minus 3. 3 squared is 9. 9 times 2 is 18. 18 minus 3 is 15. So the limit here is just 15. I found that by just plugging in the x value that we're finding the limit as x approaches that number. All right, so part B, what's the limit of this exponential graph as x approaches 0? So I'm going to plug in 0. And you're going to know anything to the power of 0 is just 1. So nothing crazy happens there. This is a continuous function. I plug in 0. The y value is 1. That's the limit. All right, this one is, what is the limit of 5 as x approaches negative 2? Well, that's just this graph right here, right? Y equals 5. What is the y value approaching as x approaches negative 2? Well, it's just 5. There's nothing to plug in negative 2. All right, let's do a little bit more complicated one. Let's plug in 1. That's the limit as x approaches 1. So it'd be 1 squared, which is 1 plus 1 plus 2 over 1 plus 1. So that'd be 1, 2, 4, 4 over 2, which is just 2. So that would be the limit there. Again, nothing happened. There's no restriction. No indeterminate form. We'll talk about that soon. All right, part E. What's the limit of the sine graph as x approaches pi over 6? So I have to know my unit circle. Hopefully you're getting that memorized. The sine of pi over 6 is just 1 over 2. So that would be the limit. All right, let's looking at F. Let's plug in negative 2. So plug in negative 2, so that'd be what, 4. Negative 2 times negative 2 is 4. Plus 6 plus 1 over 0. So the first one's kind of weird. That'd be what, 11 over 0. But anything divided by 0 is undefined. So we could say D and E here. This limit does not exist because it is undefined at negative 2. And I can't figure out how else I'm going to find that. Probably a vertical asymptote going on there. Yeah, it's not probably. It is a vertical asymptote. It makes the bottom 0. So that's a vertical asymptote. Don't need to know. We're going to talk more detail about this later. So at a vertical asymptote, the limit doesn't exist. All right, so in the cases above, nothing of great interest or new happened when we attempt to find the limit. However, this is not always the case, considering this limit, or consider this limit. What do we get if we plug in 4? So let's plug in 4. I get 16 minus 12 minus 4 over 16 minus 36 plus 20. And if I simplify the top, I get 0. If I simplify the bottom, I get 0. So this is different from part F. F, there's a vertical asymptote at negative 2. On this one, I don't know if y'all remember this, but if you get 0 over 0, that's an indeterminate form. And we might be able to manipulate this with some algebra to figure out what's going on there. So let's go down here. Before we solve that problem, we're going to solve here in a second. But let's talk about the indeterminate forms. So we'll have 0 over 0 or infinity over infinity. Those are our indeterminate forms. So if I get an indeterminate form, there's several ways that we can still find the limit. One way is going to be factoring. So this is the same problem. I'm going to factor the top. That would be x minus 4 and x plus 2. Sorry, x plus 1. So remember the numbers that go here have to multiply together to get -4. But when I add them up, I get -3. So factor that trinomial on the bottom, I get x minus 4 and x minus 5. So if I think about this graph, when that restriction cancels, there was a hole on the graph, right? Now if the restriction doesn't cancel, like part F, that's a vertical asymptote. But this restriction of 4 cancels, which means there's going to be a hole at the graph. So if I cancel out that hole part, the part that's making it a hole, now taking out the hole, if I just plug in 4 here, then I would see what the graph would look like. So plugging in 4 plus 1 is 5, 4 minus 5 is -1. So the limit here would be -5. So when you get those indeterminate forms, factor the problem, take out, or cancel out the restriction, cancel out the factors, and then plug in your x value that you're approaching. All right, so maybe pause the video and try B on your own and then come back to it. But we're going to go ahead and do it now. So I would always just plug in 0. If I can plug in 0 and I get a number, I don't have the indeterminate form, it's easier. But if I plug in 0, that's 0. This is 0, 0 plus 0. Okay, so it's indeterminate form 0 over 0. So when we get that, we need to start factoring. So looking at the top, it's not a trinomial, but it looks like there's a GCF. The GCF is x squared. So I'll factor out x squared, and I'm left with 4x minus 5. GCF on the bottom looks like it's going to be 2x squared, giving me 3 plus 4x cubed. All right, so the restriction, this part cancels. And what I'm left with, if I plug in my 0 now, that's going to be the value of the graph if I take out that little hole, because there's a hole here. Remember, the restriction that cancels is a hole. The restriction that doesn't cancel is a vertical asymptote. And we're going to keep talking about that as we go on. So 4 times 0 minus 5, 3 plus 4 times 0 cubed. What I did was plug in 0 for the x's there. And I get -5 over 3. So that would be the limit. Something went wrong. Nope, I forgot the 2. Sorry about that. So that 2, this 2, I forgot to write it here. I plugged it in. So it'd be 2 times 3, which is 6. So that would be the answer. -5/6. All right, that's it for the part 1 of the video. I'll do the rest of the notes in part 2.